Hello friends, today I will discuss one that is regarding on design circuit diagram. The circuit diagram, one problem I will solve through design circuit diagram. That means one boolean some boolean functions is given or some boolean functions are given. We have to design as per the circuit diagram as per the boolean functions. Okay, so boolean functions are given like this. Suppose x, y, z, this three that is output we can get it based on these inputs, that is d5, here is also here actually d4, okay, d4, d5, d6, d7, d2, d3, d7, d7, like this. X output can get that is based on input d4, d5, d6, d7. Y output can get from d2, d3, d6, d7. Z output can get from d1, d3, d5, d7. Okay, these are the inputs. X, Y, Z are output. Okay, so this particular output can get from this. So if we would discuss regarding on this boolean functions, then you can see here is some addition of a number of inputs. So we can consider that is a OR gate, because very simple addition of inputs d4, d5, d6, d7. So that means here say plus operators are here. So we will consider OR gate. Okay. Similarly, output we can get x. That means if a single that is different components, that's how many number of OR gates are required to provide three outputs like x, y, z. We will decide. For one output x, that is OR gate here, OR gate here, OR gate here. Since individual outputs we got that is x, y, z, or we can get this x, y, z, then here three OR gate we can take it, but different inputs we can provide. Okay, so now we see how we can create that is a design or we can create a circuit diagram or a design circuit diagram based on this boolean function. Now see what are the inputs. First of all, what are the inputs, what are the outputs? X, Y, Z are the outputs. X output depend on d4, d5, d6, d7. Similarly, Y and Z accordingly. And OR gate we can get or we can take. So you see, now we design. You see, if we go through X output to depend on the OR gate, one OR gate we can consider based on four inputs d4, d5, d6, d7. Now we will start that design, circuit diagram design, how it will work. Okay, very simple. I will show you. Here you see one OR gate we can design. Okay, and inputs are like this. Very simple, we can write or we can draw this input. Inputs are, you see, inputs are d4, d5, d6, d7. Okay, so here starting from here d4, d5, d6, d7. These 4 inputs we will provide, okay, to the particular OR gate, and we got this x output, because x output depend on these 4 inputs. Okay, similarly y output which depend on d2, d3, d7, d6, d7. d6, d7 already made previous as per the previous logic gates or OR gate. Just we add d2, d3. Okay, after that we can get D2, D3, D6, D7 to make that is a Y output. Now very simple way we can also consider similar OR gate. Okay, here I told that D6, D7 already they have already collect from here. Very simple way, D6 first D7, here come from D6, D7 is there. Okay, D6, D7, D2, D3 you have to create it. Okay, D3, D2 here that is D3, we create D3, another is D2. Okay, now D3, D2, D3, D6, D7 for Y output, or for this gate the inputs are D2, D3, D6, D7 for this OR gate, and provide Y output. Okay, now we will see again once Z output dependent D1, D3, D5, D7. Okay, actually previously D5 is not made, D2, D3 made, okay, D7 made, but D5 not made. So we create, okay, D5 already there, 5x D5 already there. So D3, D5, D7, D5 already there, D3, 7, D7 also there. So D1 will create. Okay, so now another OR gate we create like this, that is Z. Okay, output will be Z. Here what you write, D1 is there. Okay, you see D1, D3, D5, D7. Okay, D1. So and down also write D1. Next is a D3. Next is a D3, D5, D7, D3. So now we collect here D3. Okay, next D5, next is a D7, D5, D7. Okay, so now say D7, here is a D7, here is D7. Okay, D1, D3, D5, D7. Okay, like this we can get logic or a circuit diagram based on this following Boolean function. These are the Boolean function. We draw this circuit diagram based on this Boolean function. It is very easy, but not so much so difficult. We can also draw. So if this kind of inputs is given, okay, you just to check it. What kind of a logic gates we will consider. Since it is addition or addition operator, so we will consider OR gate. If we dot multiplication operator or dot operator is there, then we can get or we can take that is AND gate. So based on that requirement or inputs, we will create that circuit diagram. Okay, so this is the one example. The various example also I already explained. So it is another example. Okay, so thanks to watch my videos. Thanks to all. Please subscribe my channel and please comments me to improve this channel. Okay, thanks.